joining us as we look at more telecom fundamentals. We've gone over quite a bit of material, and I believe we ended up just talking about I think it was this slide 35. We were just talking about the different mobile network operators, and those are the group that provides all the services. That would be an operator, would be probably in Ghana, that might be MTN, that'd probably be Vodafone, that might be Airtel. Those are probably full network operators where they have the radio license and all the infrastructure. A mobile virtual network aggregator would purchase some capacity from this. Maybe there's remote areas where it's maybe not profitable. So they would lease capacity on the air interface and oftentimes even parts of their network to an MVNA, a network aggregator. A virtual operator then would either buy their services from an aggregator or a mobile network operator to provide service to their customers. And again, from the customer's point of view, they really don't know who is an MNO. They wouldn't know these terms. And then enablers are ones that provide services to the mobile virtual network operators. Things like billing, things like SIM control, things like customer services, just those types of services which are necessary. So I think we ended up here. I don't think we talked about SMS aggregators. I think we didn't do this. Did we, Raphael? This is where we ended up. Yeah, I believe so. In short message service, you get short messages all the time. There's two types of short messages. One is called P2P, person to person. That's if I pick up my phone and I text this message to Raphael and it goes to him, or you do it to one of your friends. That's person to person. There's another one though that's called application to person. These are marketing, these are appointment reminders, these are anytime a machine initiates a text message, that's called A2P, or application to person. Well, these network operators, they do not want all of these companies, just think of all the different corporations. There's enterprises, there's small to medium businesses, and there's enterprises, what are called limited liabilities. There's all kinds of corporations out there. Well, they don't want those companies all coming in at one time to these mobile network operators. So they will go through what's known as an application provider. I listed some of these here, and they format these messages so they're in the correct format. Well, then they send these to what's known as an SMS aggregator. And these SMS aggregators, Anecto is one, Mata is one, PCCW, Knox Solutions. These are aggregators that will then send those messages over a separate protocol to these operators, who will then find where the subscriber's at. That's still their job, and then send them to deliver the short message. If you were to tap out a short message, you would not go through an aggregator. If you use your mobile phone to tap out a short message, that would go directly to the mobile network. But when applications do it, when a machine initiates the message, like we said, appointment reminders, marketing, those types of things, then they'll go through what's known as an aggregator. So this is just another industry participant. There's also signaling aggregators. One mobile network, let's just say you got a couple mobile networks here. We'll just say this is in Ghana, this is Airtel, and this is Vodafone. Well, they connect to hundreds of other mobile network operators for the purpose of roaming. Well, that means they need to set signaling. So an operator in Ghana would need to send signaling information to all these other providers, and just take this times maybe 100 of these mobile network operators. Well, that would not be practical. It would not be practical to have that many links. If you tied, let's say worldwide, let's say 200 mobile networks, and they all connected to each other, it would be a mess. So they have what are known as signaling aggregators, because you still need to signal between these networks. If I fly over to Accra and power my mobile phone on, information has to go from there back to my home network in Verizon in Chicago. So it has to know something about me. So there's information that goes back and forth. That's signaling information. Well, that doesn't, it wouldn't be practical for every network to tie directly to every other network in the world. So they go through certain aggregators. And I listed some here. TNS is one, Transaction Network Services. Cineverse is another one. Star Home Mock is another one. PCCW, BIX. These are all large providers that provide signaling. And they all communicate with each other. So a signaling network here might communicate with this provider, and a signaling network here might communicate with that provider. But these all talk to each other, and they route the signaling traffic. Most of that traffic is what's known as SS7, Signaling System 7, or diameter. And hopefully we'll get to talk more about SS7 and diameter in the future, depending on the generation of your network. But just, again, be aware that there are aggregators. And aggregators, one of them being for SMS, and one of them now SMS, and one of them being for, oops, there you go. One of them being for signaling, and one of them being for SMS. Another concept with mobile networks is delivering voice. Now, in the old days, it used to be just large operators. For example, maybe AT&T would communicate with large operators, maybe Bell Canada, or AT&T would talk directly to Bell, to British Telecom or Deutsche Telekom, or some of these large operators. Traffic was always measured in minutes of use. So any difference was settled as excess minutes. The originator always paid. So if a voice call originated from AT&T, they'd be charged by the minute to terminate here. But likewise, if someone from British Telecom was calling here, they would pay for that. And at the end of the month, they would do what's known as minutes of usage, and they would just settle any differences between them. One company paid the difference to the other. And it was pretty clean and straightforward. Today, it's not like that. Today, there's a whole market called wholesale voice. Wholesale voice, where you have all these different mobile network operators. This is a mobile network operator. This is a wireline operator. Then that's kind of a strange acronym. It's the PSTN, the public switched telephone network. That's just a wireline network, and maybe another wireless network. They would tie into one provider of voice services. That's known as the POP, or the point of presence. And then they would sell that wholesale voice, and it would go through these different providers until it reaches the other end. Some of those are dedicated circuits. Some of those are voice over IP. So it depends. Now, all of these operators in the middle, they try and get the best rate. This operator might get the best rate going this way, and maybe the next month they get a better rate going this way. So you really have no control over this. But if it costs, let's say it cost for this subscriber here to call someone over here, let's say it cost $1. Well, this switch would keep, let's say, 50 cents, half of that, and send 50 cents to here. This switch would keep maybe 5 cents and pass 45 cents to here. This switch would keep 45 and pass, or keep 5 cents and pass 40 to here, and so on. So that the money is distributed among all of these wholesale voice companies. And there's many of them out there. One of the problems is you have no control if a network just happens to drop your voice and collect the money. So there's not every operator is above board, let's say. So some of them might just take this and then drop the call. It's very difficult to determine that. But this is called the wholesale voice market. And it's a complete market for international traffic for voice. Oops. I'm losing something here. Let me escape out of there. Yeah, I lost this slide right here. And this is the last one. There's certain industry vendors. There's core network equipment vendors. I just listed some of these here: Huawei, Qualcomm, Nokia, Ericsson, Alcatel, Motorola. These are all equipment manufacturers for the core network inside the telephone network. There's monitoring equipment. There's IT suppliers, Cisco Systems, HP, Dell, and just to name a few. And there are providers of security and roaming value-added services, and Cellusys is a large provider of those types of services for value-added roaming, steering of roaming, which again we'll get into what that means. Security. We talked about these protocols here. They go to these different signaling aggregators. The protocols that go on here are not inherently secure protocols. There's no built-in authentication, no built-in security. So you need to protect these, and the signaling methods are going to vary depending on your generation. There's different generation mobile networks, again, which we'll talk more about those. So anyway, that's kind of the end of the first section. That's the first section on just looking at the telecom industry, on the standards, on some of the different providers, the network operators, the virtual operators. Again, high level look at kind of the landscape of the telecom industry. Now we're going to kind of zero in. If you have any questions, let me know, please. We're going to kind of zero in on another area that's very important in mobile telephony, and that is your numbers. Not all numbers are the same. In the wire line world, we got some old wire line phones here. This is what you're known by. If you have a phone, a dedicated phone in your home or your office, and I want to call you, that's all you're known by is that telephone number. In the mobile world, you have a lot more than that. You have a telephone number that I can call you on. You have various temporary numbers. You have equipment identifiers. You have, every one of you have a unique international identifier. You have various local identifiers, various cell identifiers, routing identifiers. So there's all kinds of different numbering in mobile telephony. So I think it's important to understand the numbering and how these numbers are used in the mobile world. So let's take a look at those. Now, these mobile numbers are identified by where the specifications are identified, and that is a group called 3GPP, Third Generation Partnership Project, 3GPP.org. And this is where you get all the specifications for mobile telephony. This is all of the coders, the decoders, the core network signaling, the radio interface, any security issues. It's just, there's literally thousands and thousands of documents. We're going to do that later. We're going to go into the 3gpp.org. I listed how you get into there. You go to this website and click on these. We're not going to do that now. I want to go a little bit further, maybe within next time or the time after, we can go into here and download some of these documents. Because for telephony, it's important to at least understand where you can find specifications. You're going to long forget what I look like. You're going to long forget what I said. But if you know where to go for information, that's going to be kind of a key thing, regardless of what generation or anything else. So anyway, we'll do this later on, but this is the primary website, and this is the one document, this 23.003, which defines all of the numbering, the addressing, and the identification for mobile telephony. So we'll come back to this. Yeah, please. Say that one more time. I didn't hear the first part. Is it what now? Yeah, good point. 3GPP came about in 1990. Actually, it was December of 1998. So what it was before that, the telephone specifications for second generation mobile, which is called GSM, they were written primarily by ETSI, the European Telecom Standards Institute. They wrote the standards, but there were other groups that were writing standards for telecom. Well, before it got too out of hand, you can't have too many groups writing all different standards. Nothing will end up working. So what they did was they formed a consortium. And it was late 1998. It was right at this was almost the turn of the century. We're coming into a new century, and we're going to now call our latest phone third generation. Second generation was 1990s GSM. First generation was the analog phones of the 1980s. So now we're going to be a new millennium, a new decade, a new everything. And so they called themselves 3GPP, Third Generation Partnership Project. Okay, this is time frame 1998. Time goes on, and the standards for 3G become the standards now, newer ones for 4G. And now we're into 5G. So, but the organization that writes these standards is still called 3GPP, Third Generation Partnership Project. I think they might have jumped the gun and called it. They should have called themselves maybe something different. But I don't think back then they ever thought that there'd be a fourth and a fifth generation. Now it seems like every 10 years, changing generation. So that's how the name got there. But it's still a valid organization.
Okay.
Does that answer the question?
Understood. Yeah, well understood.
Okay. Now, first of all, in mobile telephony, not all numbers are the same. There are really three types of numbers. The first one is what's known as a telephone number format, and that's known as what's known as an E.164. E is just in the International Telecom Union. They write other standards, not only 3GPP, but the ITU, the International Telecom Union, also writes different standards. And one of the kind of the high level things that they write is numbering, and that's in the E series documents. Later on, we're going to look at SS7. That's in the Q series documents. But anyway, in the E series documents, there's a number. Again, I don't know how they got that number, but it's just called an E.164. And what that is a telephone number. An E.164, this is your telephone number. It's made up of a country code, it's made up of a national destination code, and it's made up of a subscriber number. The country code for Ghana is 233. So if I wanted to call Ghana, I would have to do plus 233, because that gets me the country code in Ghana. And then beyond there's national destination numbers and subscriber numbers. In Dublin, Ireland, the country code in Ireland, the country code is 353. The national destination code, it really depends on the network. I'm not sure what they are, but there's a national destination code. So it's made up, and it maxes out at 15 digits. It's made up of the country code, which is 3 digits long, up to 3 digits, the national destination code, which is normally 2 or 3 digits, and then your subscriber number, which is up to 10 digits. So that's your telephone number. My telephone number for my mobile phone is country code 1 and 708-921-7972. That's a complete E.164 number. Now, in mobile telephony, they assign that to your telephone number, and your mobile telephone number, it has this strange name of MSISDN. Now that's an archaic name. It dates back to the 1990s. That's Mobile Station ISDN. ISDN was a technology of the late 1980s called Integrated Services Digital Network. Not important, but they name your phone number. So your telephone number that your family and friends use to call you is your MSISDN number. It is an E.164 number. We'll look at this more later, but entities, we haven't defined these yet, but entities within a network. These are pieces of hardware in the network. Your mobile switching center, your visitor register, your home register, your equipment register. All of these things are also assigned a number. So just kind of right now, be aware, it's just a plain, like it shows in the lower right corner, it's a plain dialable number, okay? That's your telephone number. That's the first kind of number, E.164. There's another telephone number, another number that you don't know what it is, and that's called your IMSI, your International Mobile Subscriber Identity. And that's now made up of the mobile country code and mobile network code. In Ghana, the country code is 233. The mobile country code is 620. So if you have an Airtel or MTN, or if you have Vodafone as your phone, your IMSI starts with 620, because that's your mobile country code. Your mobile country code is made up of the mobile country code. I'm sorry, your MC is made up of the mobile country code plus a mobile network code, plus some kind of identifier, which identifies a unique subscriber. This is how the network finds your home network. If you get on a plane and fly over to Dublin, you power your mobile phone on, over the air interface is going to come this number, not your telephone number. Your telephone number, they don't care about the telephone number. All they care about is your MC, because that identifies who your provider is. Your mobile country code is 620. If you have Airtel, your mobile network code is 3 or 6. If you have Vodafone, it's 2. If you have MTN, mobile network code is 1. So it's always going to be, if you have MTN as your mobile phone, when you power your mobile phone out comes your IMSI, your International Mobile Subscriber Identity. So it'd be 620 plus 01 plus whatever your number is, whatever you as an individual number is. Now, your IMSI is known on your SIM card, and it's known in the home network. It's not known anywhere else. Your mobile country, your IMSI, you can't go into your settings and get that. That's a number that is just basically kind of like a secret number. It does go out over the air interface. So this is how networks find you. This is how, if you get on an airplane and you land right here, you land in Dublin, you power your mobile phone on, out comes your IMSI. And your IMSI is going to be, let's say you have a Vodafone, it's going to be 620, 62002, and then some number. So the network will say, oh, 62002, I'm going to send that to Vodafone in Ghana. That's how it finds you. It finds you that number is always there. It's your number. If you change providers, if you say, oh, I don't like Vodafone, I'm going to go to Airtel, they'll give you a new MC. You won't know what it is. You keep your telephone number so family and friends can call you, but your MC is assigned by the provider. Okay, so those are two numbers. First number is what's known as the E.164. That's a telephone number format. The next one is called an IMSI, and that's an E212.
Okay.
There is one more that is, we're not going to get into details on this yet until we get into SS7, but this is used for routing, and it's called the E214. It's called a mobile global title. Basically, it takes the mobile country code and it makes it whatever the country code is. It takes the mobile network code and makes it whatever the national destination code is, and then it keeps that number the same. And it's a number used for routing. It's nothing else except for routing. And again, that's not going to be really clear right now, but it's a routing type of number used to route some messages. North America doesn't use this. Most of the rest of the world does. So really, the two biggest numbers that you have in mobile telephony are your E164 and your E212. E164 is what your family and friends use to call you. That's what everyone knows you by. Your E212 is very important, though. You don't know what it is, but that's how you're billed. That's how the network commands your mobile to hand over to another network. That's how your mobile pages you. That's how it delivers a short message to you. Everything the network does to communicate to you is not your phone number. It is your IMSI, your International Mobile Subscriber Identity. Very important number. It's also one that's very sought after by people that want to commit fraud. Because if they can find out your IMSI, they can then power their mobile phone on and they can become you. And unlike a wireline phone, if I did something on your wireline phone, you'd pick it up and there'd be no dial tone. How do you know when your mobile phone's not working? Other than you might say at the end of the day, wow, I usually get 5 calls every evening. I've got none today. So anyway, this is a very, very important number, and this is a number that has to be protected in the network.
Okay. Hello. I have a question though.
Yes, please.
Yeah. So regarding the E164 and the E122, with those numbers, is it the same 3GPP that divides the structure of the the structure of the
N-
numbers, or?
No, these structures are defined by the ITU. Now, the 3GPP would tell you this is this is it follows this plan, but the actual E164 comes out of the ITU. The the 3GPP though would tell you, okay, the E164, this is what it's made up of, and this is how it's used. We're going to use it like this in the network.
Yeah.
So
Okay.
it's really comes out of it really initiates at the ITU, but 3GPP follows that plan. So if you went to the 3GPP specification, it would tell you, yeah, this is what it this is the structure of it. But it really initiates at the ITU, the International Telecom Union.
Okay. Okay.
Okay.
Well
Others.
understood.
Okay, let's go on a little bit more today. Let's just do a little bit more.
Yeah.
This is your telephone number. So if I want to pick up the phone, this is you. You're over here. And if one of your friends over here picks up the phone and dials your telephone number, the network will route that call to your switch. This is called the mobile switching center. So this is the public switch network. It could be a wireless to wireless too. It could be your friend that has a wireless phone talking to wireless. But what it's going to do is going to set up these voice paths. Not every switch in the wire line or every switch in the wireless, they don't all connect together. They connect with other switches. So depending on the distance, this might be a different city. But these voice paths will be set up, and the network routes for voice, the network routes on your E164 number, on your MSISDN, your mobile station ISDN number, your telephone number. So it's how the voice call is routed to the recipient's home network. Now, if I call one of you on a mobile phone, doesn't matter if I'm mobile or not. Let's say I call you and you're on a mobile phone, the call gets set up to here. It is now the job of this mobile switch to what? To go find you. How does it know where you're at? You're a mobile phone. You might be across town, you might be at work, you might be in a different country, might be roaming somewhere. So it's the job of the terminating switch here to go find you. But the voice network will set that call up right to your switching center, called the mobile switching center. And it's routed for voice on your telephone number. And your telephone number is called an MSISDN. We haven't talked about any of these things yet, but in mobile telephony, they assign E164 numbers to devices within the network. In other words, pieces of hardware in the network. We're going to talk more about what all these are later. But just right now, just keep in mind that all these different parts in the network, all these different pieces of hardware to make your mobile network so it can be a mobile network, all those are assigned a E164 number. It's not a dialable number. If you dialed one of those E164 numbers, it wouldn't go anywhere. It's a non-working number, but it is a number in E164 format. And we know that E164 format is this. Is this. E164 is your mobile country code. I'm sorry, one more. I have a lot of trouble with this thing is not working. My page forward is not working all that well today. All right, let me do one more slide, then we'll call it a day.
Before that,
Sure.
can I jump in?
Yeah, absolutely.
You mentioned about a certain concept. It's new to me. You said if I have a SIM, let's say I'm using Airtel Tigo, and then I want to change it to Vodafone. Can I still maintain the
Oops.
same number I'm using? Can I?
Okay, what you're saying is let's say you have Airtel now and you get mad at Airtel and you want to go to Vodafone.
Yes.
Okay, that's number portability. You can keep your E164 telephone number, that stays with you, but they will give you a new SIM card. They will give you, or at least a new identity in the SIM card called your IMSI,
Okay.
because your IMSI is what the network needs to find you, to page you, to bill you, and that's done by the home company. And the home company is what assigns your IMSI, your International Mobile Subscriber Identity, because the IMSI points to an individual. I'm having Alexa a lot of trouble today. Your IMSI points to here. Your IMSI points to this.
Okay.
Your IMSI, your mobile country code plus your mobile network code, those two things together provide who the network operator is. There is one second, there is a website. If we go to here, we go to, I go to www.mcc-mnc.com. Mobile country code-mobile network code.com. If I go there, there's a listing of all the mobile country codes alphabetically. So in the world, it starts with Abkhazia, then Afghanistan, and so on. So if I do a search on Ghana, Ghana, here's the networks in Ghana. Your mobile country code is 620. Your mobile network code is 3 if you're Airtel. Your mobile network code is 6 if you're Airtel. There's a company called Glo, G-L-O, which is OS mobile network code. Then you have MTN, National Security, Surfline, and Vodafone. But your country code is 233. So if I call you for a voice call, I've got to call 233 plus 233, and then if you power your mobile phone on somewhere, this is the number right here. This is part of your IMSI. That's what's going to direct that telephone network to find your home network. Does that make sense?
Yes, it really makes sense.
So this then is, we come back to here. This is how your telephone number, your MSISDN, your E164 telephone number is used if someone calls you. However, this is how your IMSI is used. Your IMSI is stored on your SIM card in your mobile phone. Your IMSI is also stored in a device called the Home Location Register in your home network. You could be anywhere in the world. When you power your mobile phone on out of the air interface, your IMSI, it's not sent here, but once it's known. But the first time when you're not known, your IMSI comes out over here. So this cell tower picks up your International Mobile Subscriber Identity, and it sends it to the switch. The switch says, hey, there's a user, and here's the IMSI. The mobile switch asks its own internal database, hey, do you know who this is? And if the database says, yeah, I registered that subscriber, so I'll make note of their signal strength. But if it doesn't know who you are, it's got to find your home system. And the only way it finds your home system is that IMSI, mobile country code, mobile network code. And it'll find your home network based on that. It says, here's their location. Tell me something about that user. And what does the home system do? It sends a copy of your profile to the visited system. So now that your profile has all of your restrictions, it has any supplementary services. If you have call forwarding, call waiting, anything that it needs to know about you is now given from the home system, makes a copy of it, and sends it to the visited system. So that's how your IMSI is used. That's how your E212 is used. Your E164 is used for when I pick up the phone and call you, but your E212 is used when you power that mobile phone on. And the system will use that number when it wants to page you, when it wants to bill you, when it wants to hand over, when it wants to find you. It uses that MC. Everything inside the network now is based on that MC. Okay, I think that's a good place to
Yes.
finish up for the day.
Yes. Thank you very much, Steve.
Does that make sense? If it doesn't make sense, let me stop sharing here. And I'm going to move you over now to my front screen so I can look at you straight on. There we go. If it doesn't make sense, let me know, because these are important concepts. Again, I know a lot of this is new material, so if you have any questions, just kind of write them down, and yeah, we'll address them. Or if you want, just send me an email, steve@cellulosys.com. Just say, hey, this wasn't clear. I have a question. Please, it's important that you kind of understand this. And I know numbering identities are a little bit different, but in the mobile environment, it's all is very important. And we'll see this more as we look at the signaling and look at the generations.
Okay. Thank you very much, Steve. Yes. I believe
Enjoy the rest of your evening. It's noon. It's 7. I'm gonna go have some lunch right now, and it's noon. We've already it's kind of a cold day out here, so yeah, we'll see you on Friday at the same time.
Yes, you too.
Okay, thank you very much, everyone. Thank you. Yeah, thank you.